Bismillahirrahmanirrahim. Allahumma rabbi zidni ilma. Bismillahirrahmanirrahim. Assalamu alaikum. Welcome dear students in the subject of Internet Architecture and Protocols. It's Ghulam Yasin, lecturer in Computer Science, University of Education Lahore at DG Khan campus. Dear students, our today's lecture topic is IPv6, IP version 6. In the previous lectures, we have discussed about IP version 4. IP version 4 was based on 32-bit address, which is logical address, which is dynamic address, and this address is compulsory while we use local area network or wide area network. But the problem was there in IP version 4, limited IP address space according to the current situation or the demand of the universe, which is using different devices in local area network or wide area network. So IP version 6 is enhanced version of IPv4, and in this version the limited space or limited address space problem is being resolved. So we will discuss in detail about IP version 6 in our today's lecture. IP addresses. An IP address is a 32-bit binary number. Dear students, this is relevant to IP version 4, which contains 32-bit address. Second point, IP addresses are used by the IP protocol to uniquely identify a host on the internet. As just I have told in previous slide, every device which is communicating on the internet must contains a specific address, which is IP address. Next point, IP datagrams, the basic data packets exchanged between hosts, are transmitted by some physical network attached to the host, and each IP datagram contains a source IP address and a destination IP address. Every packet which is transmitted from sender to receiver must contains the address of sender and the address of receiver. So the sender address will be source IP address and the receiver address will be destination IP address, and if IP version 4 is being used, then this address will be of 32-bit in binary number. So in this slide we have learned that every packet which is transmitted from sender to receiver must contains source IP address as well as destination IP address. IPv4 problems. There are 2 points in this slide. First point, that is seen to standardize on a 32-bit address space mean that there were only 2 raised to the power 32, which is 4294967 IPv4 addresses available. What does it mean, dear students? It means that at the same time in all over the world, maximum devices which can be used internet facility may be equal to 2 raised to the power 32 address space. But if the devices increase, like nowadays many devices are being added while using internet facility, IPv4 in the near future will be insufficient to provide IP addresses to all the devices which will be used on the internet to avail the internet facility. So second point, during the early days of the internet, the seemingly unlimited address space allowed IP addresses to be allocated based on requests rather than its actual need. In the previous internet packages, we have used dial-up mechanism in which just we use the internet for some specific duration or some specific time period. But nowadays, you know that in all over the world, internet facility is being used for 24 hours or 24 by 7. Like nowadays, there are online classes and students must use internet package in this way that they are online for maximum duration of time. So in this way, internet is being used not for specific duration of time, but internet is being used like 24/7. Why IPv6? Dear students, why we use IPv6 while we have IPv4? So there are three main points. Point number one, deficiency of IPv4. Just we have discussed in the previous slide, limited address space while the current need of the universe for providing internet facility to every device. Second, address space exhaustion, because address space is limited, so that's why we have to switch on IPv6. And next, new type of service integration, because new type of services are being developed, so we need IP addresses on a wide range to provide internet facility to all the devices. There are more other points about why we use IPv4: multicasting, quality of service, security, and mobility. So what is multicasting? When we send data more than one device, this is called multicasting. There is quality of service over here, there is more security over here, and there is mobility. It means that we can move devices while using IPv6. So IPv6 is enhanced version of IPv4, which provide a very sophisticated services to its users. Advantages of IPv6 over IPv4: large address space. IPv6 contains large address space while we compare to IPv4. IPv4 contains 2 raised the power 32, but over here 2 raised the power 128 address space is available. Better header format. IPv4 header format or IPv4 header contains very large amount of fields, but IPv6 header contains very limited fields. There are new options in IPv6. Allow for extension. Extension means again attachment of multiple devices. Supports for resource allocation. Dynamic resource allocation is over here. Supports for more security. Nowadays, network security is very important while we use internet or wide area network. So IPv6 provides more secure feature while data transmission, more ciphers, more different algorithms are available in network security as well. Support for mobility, we can move from any location using IPv6. Traffic class. Dear students, the concept of classes we have discussed in ATM, which was our WAN technology, asynchronous transfer mode. So the 8-bit field in the IPv6 header is available for use by originating nodes and or forwarding routers to identify and distinguish between different classes ATM, which is asynchronous transfer mode, on priorities of IPv6 packets. So the concept of ATM classes was on the basis of users' requirement, data will be or bandwidth will be allocated to users. So there were 4 different classes, and on the basis of priority we allocate bandwidth to users. So this traffic class concept is in IPv6, which is enhanced, and using this concept we can allocate bandwidth to its users according to their needs. IPv6 flow label. Flow control is very important concept in computer network. So flow label is used for flow control. Related sequence of packets. Every packet must contain a specific sequence number by which we can control flow. Second point, identified by source and destination address plus flow label. Third point, routers treats flow and sharing attributes. There are multiple attributes, for example, path, resource allocation, discard requirements, accounting, and security. May treat flow differently. Buffer size, different forwarding precedence, different quality of service. So dear students, every device which is transmitter or receiver device contains a specific buffer. So buffer size may vary. So according to this variance, buffer size, flow control may treat it differently. But main point in this slide is IPv6 provides flow label which is used for flow control. Hop by hop options. Dear students, first of all, you must know about what is hop. This is HOP, hop. While we use wide area network, then from sender to receiver, there are thousands of devices which are called switching devices, and these devices are normally routers. From one router to another router, there is a link, and from sender to receiver, let's suppose if there are 20 routers, then these are 20 switching devices. In network term, this concept is called hop. For example, if we count how many devices are between sender and receiver, we will say that there are 20 devices. So we can also say there are 20 hops from sender to receiver. So hop count is basically the counting of connecting devices between sender and receiver. Now we will study from slide. IPv6 delivery and forwarding options are moved to extension headers. The only extension header that must be processed to each intermediate router is the hop by hop option extension header. So hop by hop option is available in IPv6, which is basically counting of devices between sender and receiver. Second point, this increases IPv6 header processing speed and improves the performance of forwarding IPv6 packets. Dear students, in second point, this is discussed that while packet will be received by router, router will transmit that packet to its forwarding links. So hop by hop option will be helpful for the switching devices to take decisions for data or packet transmission. IP addressing models. Dear students, there are two models of IP addressing. First is local and second is global. We will discuss over here. There are 2 points in this slide. First point, addresses are assigned to interfaces, not hosts. Every device contains interface like Ethernet 0 interface or Ethernet 1 interface. So interfaces are used to assign IP addresses. Interfaces expected to have multiple addresses. Every interface will receive packet and will forward packet. So on every interface, when the packet will be received by a switching device or router, this contains a specific IP address. When that packet will be forwarded, next packet will be received, this will be again have a specific IP address. So every packet which will be received by the interface must contains a specific IP address. So in this way there will be multiple addresses, or if there are more than one interfaces, more than one addresses will be deployed on those interfaces. Addresses have scope local, global. Local scope means within a specific range or specific network. Let's suppose this may be in local area network, or this may be from node to node or device to device. And what is global? This is like internet, or this is for wide area network, which contains a global address scope. Transition from IPv4 to IPv6. Dear students, there are three major concepts of IPv6 which are being discussed in coming slides. So transition strategies are dual stack, tunneling and header translation. ये तीन important transition strategies हैं जो हम follow करते हैं IPv6 और IPv4 की ट्रांजिशन में। इसका मतलब ये है कि अगर एक नेटवर्क में IP वर्जन 4 यूज हो रहा है और दूसरे नेटवर्क में IP वर्जन 6 यूज हो रहा है, तो किस तरह से इनकी कम्युनिकेशन होगी इन टू नेटवर्क्स की। सो डिफरेंट टेक्निक्स यूज होती हैं, जिसमें डुअल स्टैक, टनलिंग और हेडर ट्रांसलेशन है। क्योंकि अभी 100% IPv6 डिप्लॉय नहीं हुआ नेटवर्क्स में, तो नेटवर्क्स स्टिल IPv4 यूज कर रहे हैं, और अगर IPv6 पर नेटवर्क स्विच हो चुका है या हो रहा है तो उसमें डाटा ट्रांसमिशन किस तरह से होगा, उसके लिए हम ये ट्रांजिशन मेथड्स या ट्रांजिशन स्कीम्स यूज करते हैं, जो हम नेक्स्ट स्लाइड्स में डिस्कस करते हैं। डुअल स्टैक, there are 3 points over here. Point number 1, when a network is configured as dual stack, each device on the network is configured with both an IPv4 address and an IPv6 address. In this case, if the communication is based on IPv4, then the data will be transmitted, as well as if the communication is based on IPv6, then data will be transmitted. So dual stack will help to transmit data in both cases. Second point, a dual stack network is a network in which all of the nodes are both on IPv4 as well as on IPv6 enabled. So both addressing scheme is enabled over here in dual stack mode. This is especially important at the router, as the router is typically the first node on a given network to receive traffic from outside of the network. So router is a switching device which is used to receive packets from the sender or from the previous router. So dual stack must be enabled on routers so that router will be able to receive IPv4 address packet as well as IPv6 address packet. Tunneling. Dear students, tunnel concept is basically when we use IPv4 as well as IPv6 based network. So if we use IPv6 traffic and the existing network is on IPv4, the tunneling provides the feature to translate and to data transmission. So there are 2 points over here. Point number 1, tunneling provides a way to use an existing IPv4 routing infrastructure to carry IPv6 traffic, and IPv6 or IPv4 hosts that are interconnected by an IPv4 infrastructure can tunnel IPv6 packets between themselves. So in this way, if we use IPv6 based traffic and the existing network is on IPv4 based, IPv6 data traffic can be transmitted with the help of tunneling. Header translation. This is third transition scheme. So in header translation, stateless IP is Internet Protocol, ICMP, which is Internet Control Message Protocol. So ICMP translation translates between the packet header formats in IPv6 and IPv4. So this header translation scheme is used for the translation of headers because IPv4 contains its header and IPv6 also contains its header, while data transmission will be between IPv4 and IPv6 base network. Header translation is also compulsory. So header translation is done with the help of header translation mechanism or scheme. Second point, the SIIT method defines a class of IPv6 addresses called IPv4 translated addresses. Different addresses are used for header translation mechanism. So these were three methods of transition from IPv4 to IPv6. We discuss about dual stack, we discuss about tunneling, and we discuss about header translation. So these were three transition strategies from IPv6 IPv4 based traffic network. Advantages of IPv6 over IPv4. Dear students, this is in tabular form. So there are some features which we will just go through over here. Features: source and destination address. In IPv4 32-bit address, and in IPv6 there are 128 bits addresses. IP security, second feature. In IPv4 this is optional, but in IPv6 this is compulsory or this is required. Payload ID for quality of service in the header. In IPv4 there is no identification, but in IPv6 we use different flow label fields. Fragmentation. In IPv4 both router and the sending hosts. In IPv6 only supported at the sending hosts. Header checksum. In IPv4 this is included, and in IPv6 this is not included. Resolve IP address to a link layer address. In IPv4 broadcast address resolution protocol request, and in IPv6 multicast neighbor solicitation message. It's our last slide of today's lecture and the topic is continued. Advantages of IPv6 over IPv4. Feature: determine the address of the best default gateway. In IPv4 ICMP router discovery, this is optional. This discovery is used for the connected devices, for the connected routers alive. And in IPv6 ICMP version 6 router solicitation and router advertisement is required, in which router will send an advertisement and the connected devices will reply back. Second feature: send traffic to all nodes on the subnet. In IPv4 we use broadcast scheme, and in IPv6 we use link local scope all nodes multicast addresses. Over here just the addresses are used to whom the data will be transmitted. Next feature is configure address, which is configuration. In IPv4 manually or DHCP dynamic host configuration protocol is used to assign IP addresses. So there are two mechanisms. We can assign IP addresses manually or we use DHCP. When IPv6 there is auto configuration, there is no concept of manual IP addressing over here. The last feature is manage local subnet group members. In IPv4 we use internet group message protocol, and in IPv6 we use MLD, which is multicast listener discovery. These are protocols. IGMP is a protocol and MLD is also, which is used for the subnet group membership data transmission. So in this way we have completed our today's lecture. So dear students, thank you very much for your concentration, for your learning, for your passion. I hope best of luck for all of you always.